Hi, and welcome to the next video in the series by Allen Global Consulting. This video, we're going to deal with two topics. We're going to deal with decisions, and then we're going to have some fun playing with strings and some of the functions that can be performed on strings, which is something we do on a regular programming. So let's first start off with decisions. Um, the most simplest of all and the most common decisions made by computers are logical. That means you either have a yes or a no answer. Progress allows us to have another condition, which is null or question mark. But generally, in all programming languages and the basis of computers in general is yes and no, on and off, one and zero, binary. So in in progress, while we're working on this particular um, topic, we're going to declare some variables. I'm going to declare a logical variable, and it's simple. If this is yes, then I'm just gonna message we passed the test. Um, Else message we failed the test. Right? That's an either or condition, very simple. And if we ran this right now, we'll see that progress assumes no is the default setting of this variable. So if we indeed then set it to yes, we get the yes answer. Okay, so then we have the idea now of the simplest branch of logic, which is there are two answers, yes or no. But things in our everyday lives are a little bit more complicated, right? Um, for instance, if I am at a roundabout, there's more than one exit off the roundabout. So I might want to take the first exit off. There's the second exit off, the third exit off, or I might want to go right back around and do a U-turn. So there are multiple options. So in this scenario, we're gonna create another variable. Just call it test marks, and I'll just make things nice and pretty a little bit. And we're gonna go if test marks equals a. So basically, we go else if, and we can keep going that way. Else if okay. So the last one would be a single else as regular. Okay. So I'm just gonna copy some of the stuff that I did before while prepping. This will make things go a lot faster, and so we can cover as many topics, as much ground as possible. um, Okay. Second example. So we don't want both things running at the same time, so I'm just going to block out the first example here. And for the second example, we'll go. So we're going to run it, and I know it's not done. Oh, we're missing variables. Okay. And this is part of programming we should always test. It says your grade is blank, which improves your class score by 40 points. Remarks, please ask for help. Okay. Well, this is something that happens very common in programming. We write code, we go through, find all this logic, we did all the best, everything right, but we didn't initialize or set up default values for our code. Basically, we never told it what mark we got. So let's give person a B, and let's see how it runs differently. Okay, so now after setting the grade, the message looks and everything performs as the way we expect. Okay, so people refer to this structure as a nested if-else. But basically, it's just a way of making different options off of a decision, which is more complicated than just a yes or no. And in this particular language, Progress, we can do the exact same thing in a better, what I considered a more structured way. There is the case statement with its branches. So I'll show you what that looks like. The exact same code as above, just as a case statement. This is a bit off the screen. Give me a minute. Do this. CW. CH. So I have a certain accelerator or macros, and when I type in CW, it gives me this little correspondence that I can use to fill in defaults when the code explodes. And so it then created this structure here for me. I have a C, a D, and that's the beauty of Progress. It reads like English, and so when I type this last condition, it is perfect, right? If it sounds like you're having a conversation, which is why I find it to be a very powerful language. You have a case statement. It's based on the CH test mark, just like it was up here. We had the if, else if. So it's saying, hey, you know what? Check the options out on this particular variable. Well, one of the options I'm thinking about is A, B, C, D, and otherwise do this one. All right, worst case scenario. So we can copy this sort of stuff here, drop it. Is that even B? Yeah. and you can see I'm just copying it as is, um, because there isn't really a difference, but the way how it reads in the long run, anybody trying to understand the code, um, and it makes things a lot less complicated in the long run. So I can just do this. We can block out. We have the initializer B again. Let's just move this closer to where we're actually using it. I'll say it was a lot of headaches having to scroll up and down. I didn't use it right. Oh, forgot the S. There we go. So here we get the message. Here we got grade B. And if we got an E, that falls into the otherwise category. And it says, well, hey son, you really need to improve your marks. Okay? So that's logical and decision making in a nutshell. It is the most interesting part of programming because this is one of the things that you must understand as part of logic sets, what the decisions are and what the options are and how to handle each option. Later on, we're going to do a lot of pseudocode based on solutions for some games and some problem solving. And having the idea of solid decision making and how to structure it is critical. I'm going to move on now to strings. But before that, we have to take a sidebar, and I think I will have a little decision assignment for you, and I will place that in the materials folder. And you can either write that in pseudocode or in actual progress if you dare. I would love to see it, and you can email me. So the handling of strings, I want to make sure we fully understand certain concepts. So before we can honestly talk about strings and character sets, I want us to first talk about ASCII. Now, we know that computers are based on one and zeros, and so it's a building foundation, right? That's the minimum block, and then it became blocks of 8, and then blocks of 16, blocks of 32. But now we talk about Windows 64 map, right? So now we're even using bigger sets of single units to define data. That's where the 64 comes in. All right. So ASCII is one of those building blocks. So when they were deciding how to display things and how to make things, people had different ideas. But finally, ASCII won out. So it's a numbering system between 0 and nowadays 525 or 527, depending on how you look at it. But the basic set is usually between 0 and 255 actually. So this is even a more condensed set. This is what we would usually call the printable set. So the numbers in normal decimal or tens is 0 through 127, right? Which is here, and you'll see that the space bar is represented by the number 32, and the new line or new feed, which is old way of saying it, is 10, and I think form feed is 12. So if you ever had an old printer with the little circles on the side that used to, you had to line it up and put it in the printer and let it roll up, you to get to the next sheet you would use a form feed, and that sort of thing. So these numbers still have merit because people use them in different ways. But the most important thing is that each character on your keyboard is represented by a specific number, and that's an ASCII number, right? So the space bar is 32, the small a is 61, whereas the capital A is 41. Sorry, 97 and 65, and it's usually separated by the 32, the letters, capital versus lowercase. I just wanted to show you that because while we're manipulating strings in Progress and in other languages, you tend to use the ASCII value to help you manipulate some of that stuff. And that's why we're looking at the chart. And I will also put this in the materials so you have it. At my old job, I used to actually have a printed set ASCII, not this particular chart, but a smaller chart, and have it right above my monitor as a reference point. Okay, so let's talk about strings or characters. Okay, so basically, we in the definitions part, and when we define variables, we can, in Progress, we have we call the variable type character, and it's really a string of text, right? So if we define, this is going to be a little bit fun for me. Check the word as a character, right? The default setting for Progress is that all characters start out as 8. So that's how Progress, if you write a display, whenever it defines a character, it assumes it's 8 long. And you can almost understand why, because it was 8 bits, right? 8 long. But now we have the ability to cast that because we're up to 32 and 64 and long past that. But for long cards, we can do so many things. You can even import images into a long character field if we need to. But yeah, I had a little fun with this. So rather than just go through each and every possibility, I came up with this. I'll just copy it, and you'll see that I had a little bit of fun while coming up with an example to show you how we can manipulate strings. So I'm gonna run it, and then we'll talk about it. So here we have a song verse, right? And it should be very familiar to everybody. It's a Bob Marley song. But what we're doing here is, from this verse, we're saying there's 173 characters and spaces in that verse. There are 31 words. We can count them if we want, but the computer did it. There's 7 lines. It's saying if you look at the word little, that is the 11th word in this verse of the song. Sun is the 9th word in the song. rise up this morning, smile with the rising sun are the first 45 printable characters, right? There are 101, right. Position 101 is the starting location of sweet, and it repeats, and we'll show you why that is, right? So let's minimize that. Let's look at this code, right? So it just says we define a variable checking for words. We define a variable integer length as type integer. We define a variable integer number of words as integer, and we define integer number of lines as integer. Here we have the words to the verse in that song, and you see I added the char 10, which if you look it up again, it is the new line or line feed. Nowadays we call it new line or return. I think 10, 13, and 15. Yeah, I think those are the ones you can look at. So to get the length of the words, there's actually a function in progress called length. So what this does, it actually goes through and figure out how many printables are in here. And yes, it does count char 10 as a printable. But for this example, we just you can strip those out, and we'll talk about that. Actually, it's actually in here. I stripped them out later. To get the number of words, right? So we made an assumption here, and we have to be careful because it's a little tricky, but it works. We said every time there's a space, there is a word. So this is a word, it's a space, so then this is a word, and so on and so forth. So that's why the end of each each line has a space behind it. That's how we're trying to replicate it in this example, just to make it easy. And then we're saying char 10, that tells us how many lines they are. Okay. So then you see in the message, we just print the verse as it is here. There's no manipulation, it's just straightforward. We look at the verse. And then it has, the skip just means to go to the next line. It's the same as a char 10. I should tell you, char 32 means space, right? If you look it up. This skip is the same thing as a return or char 10. So we're skipping to the next line, skipping to the next line, skipping to the next line. So we just put the length that came back from this function. Number of entries is a function where it says, I'm going to look in this source, right? And this is my separator. So if the space is my separator, it means that I'm going to count everything in front of a space. I guess that's the best way to say it. So the number of entries for space would be, okay, this, oh, there's a space, so that's 1. Oh, there's a space here, so that's 2. Oh, there's a space here, this is 3. Oh, this is a space here, this is 4, and so on. Same thing for the char 10. Oh, this is a char 10, everything before that is a 1. Oh, another char 10, anything before that, that's a 2, and so on. All right. Entry. So entry says, hey, I want you now to tell me a specific value. So what is the 11th entry in this source for space? So it's going to have to say, wait a minute. Where's 11 spaces? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spaces. So guess what? That word little would be entry 11 for space. And we'll run it again so you can see. And so for the next line, we're saying sun is. So we do the same thing. The lookup says, hey, I want to find this word in the source and it's separated by spaces and it returns a number. So this would return the number if we were looking for the 11th word here. If we did little, this would actually return 11. But we're using sun, so it just counts these, and whatever sun is, it'll give you that number back. Okay, so we come now to two of my favorite functions with strings. As in math, you start inside out, right? So the most innermost function here is substring. And as it says, we're sub or dividing the string. And substring has so many uses. It's a great tool because you can even change the starting point. But most of the time, we want to start at position 1. So I'm starting here, right? And we're saying from position 1, give me the next 45 characters. So in this substring, you can say, I want 1 to 45, whatever that turns out to be. I think it is the first two lines. And then to keep things simple, I'm going to, after I get that, right, substring, I'm going to replace all the caretens with a null. So essentially I'm blanking out the caretens. So this will go away and this will go away, and the spaces will keep the distance, making it readable. Okay? And it's just saying the first 45 printable characters. So again, the substring, a very powerful piece. You have a starting point and then how many you can go. So with substring, I could have started here, whatever position that happens to be in the length, and you can cut and slice as many pieces as you want, right? So, and I'll leave you a question at the end of this one, and if you so choose, you can send it in. So we have index and right index. And for most cases, you want to use index because what it does is it counts from the left, and a right index counts from the right this way, but it still gives you a number as if it was coming this way. And you might say, whoa, that's a little confusing. But the fact is that if you're looking at long paragraphs or an entire book, you might want to do your searches from the first page, or you might want to start your searches from the last page. Or you might want to do both at the same time to cut down the length of your search. But we can talk about that. I'm sure we'll have a lot to talk about this example. So I'll just run it again so we can see the verse and how this stuff works. And you'll have fun manipulating this. So I think my question was, if you were asked to write a program, right, how would you find, right, the second word on the third line? So that's a little project you guys can try after this video. I hope it was very informative, and we'll get to talk soon and discuss all the previous videos. Thank you, and I hope you have a great day.